Nu ska vi se, continue.
So I'm Daniel, and today I'm very grateful to have Thomas Sundberg with me. Hi, Thomas.
Hello, nice to be here.
So who are you and why do I bring you into this course?
Well, I'm Thomas. I'm a developer based in Stockholm. Test infected since a bit more than 20 years now. 23, I guess, if I'm correct. I got a master's degree in computer science from KTH. And yeah, I run my own company, working as a consultant most of the time. Currently, I'm working on a project together with a few friends. So currently I'm working in a startup, I guess you could call it. So I'm building my own product at the moment.
Nice.
So that's pretty much me.
So this company that you work on, what was it now?
Yes, in my company. I had a vote. I asked my friends, what should I call my company? And they came up with one of the options that was Think Code. I don't think that was the best option that I presented, but that was the option that got most votes. So I went with that one. And basically because I spend quite a lot of time thinking and then I love coding. So nice. Therefore, some people thought that that was a good company name. And since the company name doesn't matter, I went for it.
And what kind of programming, what kind of coding do you
do? Well, almost anything related, almost anything to be honest, but mostly Java backend. And since a year back, also some front-end stuff. So I've been using React since last summer. But most of the things I do is Java backend. And the reason for that is that it's hard to test front-end stuff. There are tools that you can use, but they are not that nice to work with. There are, for example, Selenium, which is a great tool for testing web applications. And I have written the video course for Pact regarding that one, but I don't use it that much. So I mostly backend because I can test those things more or less easy.
So I can hear you like testing, right?
I do. I'd say that I am test infected. And
what does it mean to be test infected?
Some people would probably describe it as a disease or a diagnosis. To me, it is the ability to really make sure I test first. So I almost feel sick when I don't test my code because I know that I will probably break something and I won't even know it later on. One of the things with me is that I don't trust anyone, and especially not myself, to do something correct. Because I make a lot of mistakes, hundreds of them a day probably. They doesn't always end up in production. Sometimes they do, but that's not very often. Because I test drive my code and I keep my tests around. So when I do a deployment, which I do very frequently in the project we are working on at the moment, I will run all the tests and I will use them as a safety net to make sure I didn't break anything by mistake.
Nice. So if you like break down a day and the different tasks you do during that day as a programmer and as a tester, so how would you describe what you do as a programmer?
As in, do we have some kind of process on how we do the development, I suppose? Sure. I usually have an idea what we want. I tend to talk to my other co-workers. At the moment, I'm the only developer working full time. So we have I guess you could call it product owner, a person who knows the domain very well that I can talk to anytime. The domain in this particular case is the domain of teaching doctors what to do. So when you become a specialist, you need to do a lot of things and you have to spend 5 years doing it. And you have to be able to tell, in this case, Socialstyrelsen, what you did. So one of the guys, he is a specialist, and well, he knows way too much about this topic. So he will tell me how things should work and how they shouldn't work. So I try to have conversations regarding this, so I understand what problem are we looking at. I try to understand the beast. And when I don't understand, I ask for examples. So the best question I can think of when you don't understand something that someone tries to describe is, could you give me an example? It's a simple question. It's not a threatening question. Anyone hopefully can give you an example. You're not threatening anyone by asking it. And it's okay to say, sorry, I can't give you an example. Or it should work like this in this particular situation. So conversations, concrete examples, and then I start working somewhere with some kind of test. Could be an acceptance test that would test a large part of the application or a very small part.
So when you say acceptance test, because we have not touched that subject in the lectures yet. So what would you say is an acceptance test?
An acceptance test is something that verifies a larger part of the application, whatever that happens to mean. It could be expressed in many, many different ways. One of the frameworks I really like is something called Cucumber and Gherkin. I suppose you haven't talked about that either, but what you can do there is you can specify the environment or the state the program should be in, and then when you do something, you should be able to observe a new thing. So if we take it really small, say that we have a function that should be able to do addition. Addition is rather easy. We could say that we could add 1 and 2, and we should expect to find 3. Very boring example, but if we make sure that we start the application, then we feed it 2 numbers, and then we look at the result. We should be able to see 3 if we fed it 1 and 2. And that can be scaled up. So we can talk about, I don't know, if I place something in a shopping cart, if on an e-commerce site, when I check out, I should find my things, or when I check out and pay, I should get some kind of receipt. There's a lot of things going around in the background if you have an e-commerce site, but from the outside, it's a few simple things. You find stuff, you put it in your shopping basket, you check out, you pay, you get a receipt. Nice. Trivial, except that it isn't trivial. It's very complicated sometimes. But we can use an acceptance test can make sure that we perform these steps and check the result.
Okay. So you often start with an acceptance test.
It depends. I wish I could say yes, but it depends. And that's a consultant answer. If anyone here is want to be a consultant, one of your answers can always be, it depends. That will give you 30 seconds more to think about the problem. And yeah, so that's a good start. But yes, I try to start with an acceptance test often. If I know exactly what to do, I might not do that. As an example today, I'm solved an issue where we are sending email, but sometimes we miss new lines. And if you just send an email and a new line has been lost, that's not very nice. So today I converted the text email into an HTML version instead. I knew exactly what to do. I could create an acceptance criteria. In this case, it's sometimes referred to as golden master approval, an HTML file, which is what I would expect when I fed the system a few words. So I created my acceptance test in this case, and then I verified that the result looked like what I expected it to be. So I have two files next to each other, and using, in this case, a unit to verify that they are equal. Or actually, I don't use JUnit. I use, forgot the name of that one. Assert J. Assert J. JUnit has a lot of assertions. Assert J, turn them into something good.
Nice. So, okay, so now we have the acceptance test. And what do you do next?
I run the program. I run the test.
Yeah.
And then I'm happy because it failed.
Yeah.
And I mean, I have quite experience about this. I said I have like 23 years, and I remember first time I wrote code, that verified code. That was in August 1997. I remember where I were. And a friend of mine looked over my shoulder and said, well, are you stupid? Are you writing code that verifies that works? Yes, I do. We didn't have any frameworks, and it wasn't anything, what do you call that? I didn't have a process or anything like that. I just tried it out. And I shouldn't have done that because we were in a rush. And so experimenting was perhaps not the smartest idea around then. But yes, I have a lot of experience, and I always make sure I break things before I fix them. Because failing, if you have a unit test, is safe. The worst thing that could happen is that you can't solve the problem, and then you just revert until to the previous point in time where it actually did work. That's what we have version control for. So if you realize that, oh, I can't even solve this, or I took a wrong turn somewhere, now everything is broken, revert. Don't be afraid to revert. I once spent 3 days trying to solve a problem, and a colleague that could have helped me wasn't there. So when he showed up 3 days later, he said, you forgot that one, whatever it was. What I should have done was revert everything. I didn't. So I spent 2 days, or was it 3 days, following the wrong path. Very, very stupid.
So why do you why do you want it to fail? So what if your newly written test succeeds instead?
Because there's a saying, never trust a test you haven't seen fail, and seen fail for the right reason. It's not okay that it failed. It should fail for the correct reason. And that's really, really important, because otherwise you don't know if it will save you when you make a mistake later on. And we do make silly mistakes all the time. So and the way to prevent that this ends up in production is to have good habits. And testing is a good habit. It's like washing your hands. You do that once in a while, quite often recently, and we do it for a reason. We do it because we don't want to spread germs. This is a good habit.
Okay, so now we have a failing acceptance test. And what is next?
Next is 1 out of 2. Either use the acceptance test as the sole driver for fixing this part of the system. If you can foresee that it won't be that you won't have to spend too much time with it, then you might be able to use this acceptance test as a driver to drive the development.
You mean to write code in your system?
Yes. When I say drive development, I mean test drive the implementation of the production code. Yeah. So you start out with something that failed. It probably failed because the production code didn't even exist, so it couldn't even compile it. So you make sure that it can compile. Now you run it and it doesn't work because the production code is just returning garbage or something. But after some time, it will start doing something better, and all of a sudden it starts work. I use a tool called IntelliJ IDEA. I'm not sure what you use in this course.
I think some students might use that also.
Yes, that doesn't really matter, but it can help you. The tool doesn't matter in this case, but it can help you to generate method stubs. So if you write a method name and it doesn't exist, you can have the tool to create a method for you. And the default setting is if you should return something, it returns null. If it's a return type would be a Boolean, I think it returns false. So I've patched my environment, so I overthrow an exception, not implemented yet. Because then if I run this, I can't forget it. If I use this method ever, it will throw an exception at me. So that's one of the few things I do when I set up a new environment somewhere. I patch my idea to do this. So I run the tests, and sometimes the acceptance test is enough. Sometimes I realize that, oh, I need to do more things. So I start writing tests that test smaller parts. And I guess we can start talk about unit tests now. So I try to build smaller parts. I don't really like the division between acceptance tests, service tests, integration tests, unit tests, tests, you name it. They are tests for me, tests. They test different parts of the application, and sometimes you test a large part, and sometimes you don't test a large part at all. And it's easy to show that you can't just rely on one type of test in this case. You need both. You need something that verifies all of it and something that verifies small parts of it. Right. Maybe Reinsberg has an excellent talk about that. Yeah, let's not go in there. It can be shown that you need more than one thing.
So we're progressing to smaller and smaller parts.
Usually, sometimes I know where I want to be. So sometimes I start from the small part and work myself to the outside. I did that today. I wanted to make sure that a field can be mandatory in an application, a web application. I knew where I would want to specify it, so I did that, and that would be in the core of the system. And then I worked myself outwards, and a few steps later, I can show I can use the user interface with, and this field is now mandatory, which it wasn't possible 9 o'clock this morning. It was possible at about 11. But I knew what I wanted to do, and therefore I could work from the inside out.
Yeah, nice.
So I vary myself depending on the need.
Okay, so let's say that you want to implement some part. So how would you progress? Okay, so now I have something that I think might solve my test case, whatever level that test case is on. What do you do next?
Well, what do you do next? It all depends, but it's very common that I look at my production code and realize that it's not that nice. So I start cleaning, and I can do that whenever I have a green bar. If we talk about test-driven development, we also talk about the 3 phases: red, green, refactor. And we haven't seen that, but on my company logo, I have these 3 things, 3 arrows, and the blue one is unproportionately large because refactoring is very, very, very important. We probably spend more time refactoring than writing a new test. You probably spend more time refactoring than you spend implementing the functionality. So refactoring is very, very important. Can't be stressed enough.
So some of my students who are working on TDE right now think that they don't know what to do during the refactoring phase. So could you give some examples of concrete actions, so to speak, that you do in your code during the refactoring? What do I do?
Well, perhaps I look for unused variables. An unused variable is dead code. I get rid of it. I don't look ahead or think ahead too much and say that, oh, I might use that within the next 5 years. I might use it, absolutely, but then I'll recreate it. I might do some extraction of methods. Maybe the method I'm verifying is large, a little bit too large. So maybe I can see that there are 2 distinct parts in it, and therefore I might extract 2 different methods. So what I look for is the same level of abstraction.
Okay.
So if I'm doing, say, something small somewhere, bit manipulation, which is perhaps the smallest things I can think of, and things I never ever do because I don't have to. But some people think it's nice. But say that I have a part of a method where I do bit manipulation, and I have another part that fetches something from a database. They would be on very different abstraction levels. I would probably extract them into two different methods. And since I'm mostly using Java, that would probably be two private methods. I try to see, is there something I can hide here so I can make the my classes as a class should be small, but it shouldn't be too small, and it shouldn't expose too much to its environment. So can I hide stuff? Does this method really have to be public? Is it okay if it's private? Okay, maybe not. Could it be package private? And if it can, I'll try to move it there. So I use the test as a safety net to make sure I don't break stuff when I do refactoring. And sometimes people think that refactoring is you rewrite stuff. But refactoring means, by definition, you change the code, but you do not change the behavior. The code we should do the same thing, but it will do it in a better way.
Nice.
So the challenge here is what is better, and that comes with experience. We all have opinions, and we don't have the same opinions, so that could also be a topic for discussion. We could even disagree sometimes, and I think that's healthy.
Yeah. Nice. So okay, so now we're through refactoring. So we wrote a test, we wrote some implementation that succeeded the test, and then we did some refactoring. Okay, what's next?
That's a good question. Sometimes I have a to-do list of things I want to do, so it's time for next test. So maybe I do that. And when I've implemented that test and the production code, I might realize that, hey, the idea here is there could be something that we need to extract here. Maybe I find a new concept that was missing. Something was very hard to write because there was something I missed. And then I try to extract that if possible. And I would do that during the refactoring phase. So I would make sure that things work and then do refactoring again. So you always come back to refactoring. And it's also something that some people in some teams I've been working with, they say that they need, say, a refactoring sprint, or they need time to do refactoring. That's not true. You should never ask for permission to do refactoring. Refactoring is something you do, and you don't tell your boss about this. Your boss should not care. And if they do, well, you have a couple of options. Changing boss is one of them. I've done that more than once.
Okay, nice. So how many tests do you write in a day? Would you say? How many tests? Are you writing a lot of tests, or are you writing just a couple of tests?
It depends a lot. But on a good day, I haven't counted, so I don't really know. But on a good day, say somewhere between 5 and 50.
Nice.
It depends a lot on what I'm thinking about at the moment. So it's very hard to say. And I have no statistics telling me how many I have. But I can tell you that in the current project we are working on, I think we have 1,200 unit tests. We have 2,500 or 3,000 something tests in the front end, mostly because I could generate a lot of things, verifying dates and times. We also have quite a few scenarios written in Gherkin. So I don't really know how many tests we have in total. But for a seemingly small application, we have, I would assume, in the neighborhood of 4,000 to 5,000 tests.
Nice. So
it takes 5 minutes to run, and I'll do that every time I deploy.
So 5 minutes run. Okay.
Yes,
but,
which is
then you run all these tests, right? So how long does it take to write? So just if you just want to run you just changed something, did some refactoring, and you just want.
Yes.
How long does that take? You run all tests every time?
No. I would be crazy if I did that. The thing here is that some of these tests are slow, and slow means they take a second to run. So that's horribly slow. Most of my tests would take a few milliseconds, perhaps 1 second to run if I run the larger suite. But I make sure that I don't run all of it. I can run, say, just the current test class or current test method, or I can run all the tests in this package. So I choose my level, and then I use that when I do my daily work. And mostly because I want to be able to run and drive this, and I want to be in control. And if things takes, there are research done on this, which I haven't looked at that much myself, but I've talked about this, and I've seen presentations done by Åslak Ellisøy, a Norwegian guy who's the father of Cucumber, who I happen to know. He talks about, what do you call that? I forgot. But the thing here is that it's important that it's fast. And you lose track if things takes more than 10 seconds, then you tend to lose track. So if you have a situation where it takes 10 seconds to run a unit test, then you have already forgotten what you were trying to do. Or at least I have. Most of us have. We will have time, lots of time to check the weather, check Twitter, whatever you want to do, and then try to come back. So it has to be fast. And fast is on the scale of milliseconds. And it's okay if it takes 150 to 200 milliseconds, but not much more.
This first test that we wrote, the acceptance test, I imagine such a test could be much slower than the smaller grade of tested the unit.
It depends. It depends again.
I mean, if it's runs database queries and stuff like that.
Exactly. And that's why I say it depends.
So do you divide those tests into separate suites of tests?
Yes, I do. No, not slow test and fast test, but let's look at the database example. One of the things I do a lot is making sure that I can hide things like the database behind an interface. And then I almost always implement two versions of that interface. I implement something that actually talks to database. So I tend to have an implementation that actually is using SQL is the most common thing, and an in-memory solution. Because if I can trust, if they are functionally equal, I can use the in-memory solution for my acceptance tests. And all of a sudden, they can be very fast. So that was
so you just have some linked list or something that stores these objects or whatever.
Yes. The most common solution is a map.
Nice.
Because then I can map and sometimes back to the list.
So what do you call these? What do you call these? This database that is not that is in-memory database. What would you call such a thing?
The naming convention we use is that we call database functionality for repository. So that's something where you fetch stuff stolen from the domain-driven design, the folks from domain-driven design. So I tend to call them in-memory, blah, 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 repository.
Okay.
And then the production code is usually called SQL, blah, 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 repository. So I can divide them. And in production, I use the SQL version. During test, I use both, but I usually only have a test suite that will verify the SQL database at that level. And then I verify an in-memory database the same way. So I handwrite an implementation for the in-memory, and then I use that one everywhere because I can trust it. And therefore I can get speed and confidence and low cost. This was a topic on a presentation I had yesterday at IT Days in Cluj, Romania.
Nice.
It's not very hard, but it's not very common to see that. People tend to think that they have to use the correct database, for example, and you don't.
So I have a follow-up question on this. Okay, now we have two different implementations of this sort of same thing. How do you make sure that you can replace this so that you can decide that during test I'm using the fast one and during the implementation? How do you make sure that, because if I create these objects somewhere, how do I make sure that I can replace this?
Yes, I shall not say that the answer is obvious. It is obvious for me, but it's not obvious if you don't know it. I use dependency injection. Dependency injection means that an object will receive all its collaborators somehow. And the most, you can do that in many different ways, but the way I use it or do it is that I send all, make sure that all collaborators are required in the constructor. So if I have a service that needs backing of a database, then I will make sure that I can't create this service without a database. And I'm not requiring the production version of it. I require the interface. So if I have two implementations of the same interface, I just say, please give me something that implements this interface.
Nice.
Therefore, I can change it and I can get very fast tests and I can get the persistence I need in production. It may sound like magic, it isn't.
So dependency injection, remember that for the exam. So Thomas, I'm checking the clock and I see that we have 5 more minutes. And I really would like 5 more hours with you. But let's take what we have. And I think that you can choose a topic for the last 5 minutes. What would that be? What would you think that is the most important my students should take with them into their testing life, so to speak?
Maybe the fact that testing is not a goal in itself. Testing is just a tool. It's a tool that enables us to do what we really want to do. And what we really want to do, or really should do, is make sure that our users, our clients, can use this application. Because there is no point in writing a fantastic application that no one ever uses. It's like writing a song and never play it for anyone. That's just, it could be fun, but it's not very useful. So I would say that it's waste until they can use it. That's that's a text I've printed on a T-shirt just to annoy people. I'm a very annoying person sometimes. So I use that as sometimes when I'm as a consultant, I meet a new client. I could wear a T-shirt like this one, which you may or may not be able to see. It's
nice.
So that's my definition of done. And that's a very hard definition of done because some people, they are very afraid of putting stuff into production. We have to do that. Otherwise, we can't make sure that our users can use it and we can't get their feedback because it doesn't matter how careful we have been testing this. Suppose we tested the wrong thing. Suppose the application is doing something that is totally uninteresting. It's great at calculating the mass of weight of carrots for some reason. But the customer, they really wanted something that can drive a car autonomously from Växjö to Stockholm. Total different domains, doesn't have anything to do with each other. So you need to ship it. You need to make sure that people can use it. And if people say that we can't do that for a long time, a few weeks or something, ask them why. And if they don't want to tell you why, ask them why again. You do that 5 times and you probably get the answer. And if they still don't know how to do that, call me. I deploy a few times a day. I have been working with, say, for example, the ticket booking system for SJ. We were able to deploy like every 9 months or something, and then nothing worked for 3 weeks. That was a pain. somewhere where you don't want pain. So deploy often. If you can deploy often, you can also, if you're unlucky, you may deploy something that is broken, but you can fix it. Because whatever was broken wasn't broken an hour ago, so you can always revert. So it is the same thing as what I said. If you can't fix something because you took a wrong turn, revert and start over. The same thing goes with continuous deployment, which is a topic on its own. And I guess you don't talk about it here, but that's a very important topic.
No, I mean, testing is an integral part of that. So.
Yeah, but testing is just testing is just an enabler. Testing is just something that makes this safe to do. Because
but it's worth doing, right? So,
oh yes.
Okay, so we run out of time. I would really much to be able to talk to you again if you would allow me. Perhaps during the evaluation of test suites, something like that. Would you like to talk about that?
No coverage. Yeah, let's not go there.
But really now I need to say thank you. Yes. Thank you so much.